Okay, students, this is my work solution for question 6B of the May 2024 AdMaths paper. A bag contains 6 red marbles and 5 black marbles. During 2 rounds of a marble game, a student is required to randomly draw 1 marble without replacement for each round. Construct a probability tree diagram to represent this information. Okay, so originally you have 6 plus 5, 11 marbles. So the probability of selecting a red marble would be 6 out of 11. Probability of selecting a black marble will be 5 out of 11. So I've written those along the branches, and the outcomes, of course, at the end, red and black. Now, if I selected a red marble, I would have 1 red marble less in the bag, which is 5, and the new total, because I'm not replacing it, the new total will be 10. So the probability of selecting a second red marble will be 5/10. Of course, the number of black marbles would not have changed. We'll still have 5 black marbles, but the new total would be 10. So 5/10 for that probability. Okay, let's move to the second one. So if we had selected a black marble, we'd now have 4 black marbles and a new total of 10. So I have 4/10 as the probability of selecting a second black marble. If after choosing the black marble, we want to know the probability of selecting a red, well, the red, the total 6 would not have changed, but the total marbles in the bag would be now 10, so 6/10. That would be that probability. Right, we have a second part to this question using the tree diagram. Using your answer in B part 1, find the probability that the marbles are drawn are all the same color. So we'll reuse our tree diagram. And all the same color means they're either red followed by red or black followed by black. We would multiply the probabilities along the branches. So red followed by red would be 6/11 by 5/10, which gives us 30 over 110. That reduces to 3 over 11. And all black would be 5/11 by 4/10. That's 20 over 110, which reduces to 2/11. Right, so if we add those two probabilities, we'll get the 5/11. I've written my answer in this way as well. So probability of red followed by red plus probability of black followed by black. So here the two probabilities are representing red followed by red and black followed by black. Multiplying them, I would get these. And well, without reducing, I added them. I got 50 over 110, and that reduces to 5 over 11. Let's do part C as well. Given two events A and B, the probability of A union B is 0.7. The probability of A occurring is 0.3, and the probability of B complement, meaning B not occurring, is 0.6. Calculate the probability of A intersect B, meaning A and B occurring at the same time. Okay, so given the probability of A occurring is 0.3, the probability of B not occurring is 0.6, we can calculate the probability of B occurring. That should be 1 minus the probability of B not occurring. 1 minus 0.6 gives us 0.4. Right, and we need to remember this formula. The probability of A intersect B is the same as the probability of A plus the probability of B minus the probability of A union B. All right, so A would be 0.3, B would be 0.4, and we are given originally that the probability of A union B is 0.7. Now if you calculate that, you're actually going to get 0. So that means there is no intersecting region. This would be represented using disjoint sets as I have here. Right, so A and B cannot occur at the same time, and for part 2, that would be part of our answer. What's the relationship between events A and B? Right, since they cannot occur at the same time, we say that they are mutually exclusive.